Welcome to our exploration of the fascinating world of plasma physics, where we'll uncover the mysteries of the fourth state of matter. Plasma, often described as an ionized gas, is a unique state distinct from solids, liquids, and gases. It's characterized by a significant portion of its particles being ionized, meaning electrons are separated from atoms. This video aims to demystify plasma, explaining its creation, properties, and why it's considered a separate state of matter. We'll also delve into the various types of plasma, their applications, and their role in natural phenomena. So, let's dive into the electrifying world of plasma physics. Plasma is formed by heating a gas or subjecting it to a strong magnetic field, leading to a process called ionization. This is where electrons are stripped away from atoms, creating a mixture of ions and free electrons. The energy required for ionization can come from various sources, such as electrical currents, high temperatures, or intense electromagnetic fields. Plasma exhibits several unique properties that set it apart from other states of matter. These include electrical conductivity, magnetism, density, and temperature variations. Plasma can conduct electricity due to the presence of free electrons and ions, can be influenced by magnetic fields, has a density that can vary widely, and temperatures that can range from a few thousand to millions of degrees Celsius. Plasma differs from solids, liquids, and gases in its atomic structure and behavior. Unlike solids and liquids, plasma does not have a fixed shape or volume. It also differs from gases in that its particles are ionized, giving it unique electrical and magnetic properties. The formation of plasma requires specific conditions, such as high temperatures or strong magnetic fields, to achieve ionization. These conditions are commonly found in natural phenomena like stars and lightning, as well as in laboratory settings where plasma is artificially created. There are two main types of plasma: thermal equilibrium plasma, where electrons and ions are in thermal equilibrium, and non-thermal non-equilibrium plasma, where electrons are at a much higher temperature than the ions. Natural plasma phenomena include the sun, stars, and the aurora borealis, while artificial plasma is created in laboratory settings for various applications, such as in fluorescent bulbs, plasma TVs, and fusion reactors. Plasma has various industrial and technological applications, such as cutting and welding, due to its high temperature and energy density. It's also used in electronics for plasma displays and in medical instruments for sterilization. In scientific research, plasma plays a crucial role in fusion energy research, aiming to harness the power of fusion like the process that powers the sun, and in space propulsion technologies. Everyday uses of plasma include neon signs and plasma balls. Plasma is ubiquitous in the universe, found in stars, interstellar clouds, and solar phenomena like solar flares. It's also present in Earth's phenomena such as lightning and the aurora borealis. One of the main challenges in plasma physics is controlling and utilizing plasma, especially in fusion energy, which requires confining plasma at extremely high temperatures and densities. The future of plasma physics holds promising potential, with ongoing research aiming to overcome these challenges, leading to a new era of clean and abundant energy and exploring medical applications, environmental solutions, and advanced manufacturing processes. In conclusion, plasma physics is a field of immense potential and fascination. From the depths of space to the technological advancements on Earth, plasma plays a crucial role. Its unique properties and behaviors make it a distinct and essential state of matter. As we continue to explore and understand plasma, we unlock new possibilities for technology and science. We encourage you to further explore the wonders of plasma physics, as it holds the key to many future innovations. Thank you for joining us on this journey through the electrifying world of plasma, the fourth state of matter. Thank you for watching. If you're hungry for more knowledge, hit that like button and don't forget to subscribe. Your support is incredibly valuable to us.